Hello there, everyone. It's nice to see you. And today, I wanted to take a completely different direction. We're not going to do any functional game development today. Instead, I have publicly issued a challenge to make funky pants that I can out 10-liner him in Trash 80 Basic, and found myself an emulator, and I plan to do it even if he doesn't do anything. And so, let's get ourselves started. This is an emulator called Mocha, and it's Java based, and it's a little older. I've used it before. Cause yeah, I'm the kind of nerd who likes to use the basics of your. This was the very first computer that I got when I was 13 years old was a TRS-80 Color Computer 2. And it happens to run Extended Color Basic 1.1. So this is how I began. So, 10, print, you're going down at Make Funky Pants. And we will then 20 go to 10. This was always the first. This was basically the hello world of. This is always the hello world. It's like, oh hey, or it's new 10. Print. What is your name? 20 input and 30. Print hello and $sign. 40 end. Completely unnecessary to do 40 end. Run. What is your name? My name. Well, that's right. The input statement. Now, there was actually a little editor that this one had that uses commands I'm told are similar to Vi. So I actually know, or Vim. Not sure. I don't use the command line editors. Use whatever editor that comes with an IDE or whatever. I'm not all that terribly married to a particular editor. What is your name? My name is Ernie. And hello. Oh, hi, computer. So, in a 10-liner contest, you have exactly 10 lines. And the idea is to make a game. So, it's a way more challenging thing than you think, because you have those. I'll do this. Okay, print. Hello, my name is Inigo Montoya. You killed my father. Prepare to die. Hello, name is Inigo Montoya. You killed my father. Prepare to die. Hello, my name is Inigo. Such a wonderful performance of Inigo Montoya, and I'm so glad I get to do a very poor impression of him here. You killed my father. Prepare to die. Inigo Montoya. And that's what I was looking for. This is how long you can make a line. That's 1, 2, 3, 4, 5, 6, 7 lines, and 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22. Print 32 times 7 plus 22. I have 246 lines. I know that the categories for the 10-liner contest that I will link to below is 256, and this computer can't do it. It also says you can use abbreviations for things. We're going with this is what it can do. It can do 246, and so even if you counted the line number of 10, that's an extra, and the space, you still only wind up with 249. So we're easily there. So enough with an ego. But so there's also a lot of tricks you have to do in order to maximize 10 lines, because most of the time you'll have one thing per line. Something to the extent of, would you like to try green eggs and eggs? Actually, there's something I know here. Green eggs and ham. Ham. I'd like to try green eggs and ham. 20 input response. And then 30 if left $sign of response equals yes. Then we'd do a go to. So then 40 else 50. And so if you do this, let's print. Oh, good. Here you go. And end. Otherwise 50. Print. Would you, could you, in a box. Box. And so on. And so on and so forth. Print. And so let's run. I'd like to try. Oh, I did it wrong. Green eggs and ham. Yes. Oops, syntax error. List 30. What did I do? Then 40, else 50. Yeah. Yeah. Oh, you know what? Left 1. Okay. Would you like to try green eggs and ham? Yes. Oh, good. Here you go. Run. Would you like to try green eggs and ham? Anything that isn't yes. Would you, could you, in a box. So, that's not a lot of functionality on a line, but we do have somewhere around 246 characters. So we have to get clever with how things go. And so, how in the world are some of the ways we can maximize stuff like that? And one of the ways is by using functions. Now, using defn. But that only works if you count the cost and you have to use it a certain number of times. For example, I've got direct access to memory. I've got 64K. Not really. It's right here, print mem. I've got 24,871 bytes of memory. So really, the kind of thing that I want to do is I want to clear. We'll say 200 and 16383, and this tells the computers like, hey, you can have 200 bytes for string storage, and the last byte that I want to use for basic program is 16383. 16383. And you're like, well, what's the significance of 16383? I know a lot of younger folks. 16383. Well, really it's 16384. I want to start with 16384. That's 4,000 or 4000 hex. So, and 1000 is 4K. So 16K. So I say, okay, 16K, but now we print mem. Let's run print mem. I have way less, but I've only got 10 lines, so it's way less of a problem. Plus, I do have 200 bytes reserved for strings. But you take a look here, and so I want to x equals a equals x equals 0. So because x is going to be my index into something, I'm going to go peak 16384 plus x. Because I want to grab out that. I want to grab this out. And then 20. If they're related, like, oh, well, b equals peak 1. And then y, no, x is now 1. B equals peak 16384 plus x. Due to the duplication of this each time, 4 characters for peak, 5 characters for the number, parenthesis, so 4, 5, 6, 7, 8, 9, 10, 11, 12, 13 characters for me to do this each time. So 26. And if I only have that many, but I have that many characters in order to get my entire game in, I can't be doing this. However, there is a groovy little statement where I can say, we'll put it at 11, def fun a x equal peak 16384 plus x. Now, this is 6, 7, 8, 9, 10, and then plus the 13. So it's 23. So in order for this to be worth it, so I got 23. And then so 20 x equals 0. Let's say a equals. Well, we still need x. A equals fna x. So I have managed to chop it. So it does the same thing. 1, 2, 3, 4, 5, 6. I've gone from 13 to 6, and I've saved myself 7 characters. But I have the fact that I've got 23 characters that I had to spend in order to save the 7. So print 23 over 7. So I'm losing if I use fna only 3 times. And I win if I use it 4 times. So in a case like something like that, that is one potential way. Also, one of the things that can be done in these sorts of programs is you can have list. There are conditional things. So we'll do new. And we're going to clear. So I clear 32. Oops, sorry, it's 200, 32768. Print them. We should be back up to our 24, to almost 25K. Yeah, fear my extended color basic 1.1 skills, because you're going down like funky pants. Anyway, CLS. I can do things. So I say x equals random 3. Now the random function in this particular version of BASIC, it works like this. If you use a number in the between the parentheses, it'll generate an int that's 1, 2, or 3. So it's a 1-based integer with that as the max value. This becomes a very important thing in life. But so, I would say if x equals 0, then, not 0, it won't be 0, then, and here's really the thing, if x equals 1, then 30, else if x equals 2, then 40, else if x equals 3, then 50. And this is actually a rather bad example because there's a special statement for this. There's an on go to. I'll just show that right quick. I could have go on x go to 30, 40, 50. But the whole point here is I have these conditionals, and but I can't nest them, because if I wanted to have, so another 30, print Mo, and 40 print Larry, and 50 print Curly, and I really more identify with Curly. So run Larry, run Mo, run Mo. Let's get a Curly. Come on, Curly. Hey, Curly, where are you? There we are. Thanks. See last list. Okay, so I can do multiple things on the line, but what I cannot do is if, okay, then we'll go with a 15, y equals R&D 3 also. Edit 20. If x equals 1, then, I'm not sure here, so I'm going to insert if y equals 1, then 30, else, so you know what, I'll leave this. I'll actually leave, oh, edit 20. I'll actually leave a Three Stooges theme here. Delete, delete. But I'm gonna gotta put Curly first, so this is gonna be a 3, then 50. Otherwise, else if x equals 1, then 30. You know, it's true. So 60, we're going to print Shemp, and 70, we're going to print Curly Joe. So, alright, there's that. So if x equals 3, I want to edit 20. And maybe this kind of works and maybe it doesn't. Let's find out. Delete, delete, insert if y equals 1, then 50, else if y equals 2, then 60, else if y equals 3, then 70. So, this one I suppose will work on Curly, Mo. But there are other things where if I want branching logic, this quickly becomes really, really awful. Because, okay, here I'm already 2.5 lines, and I got 7. Because really the thing, so let's take it, so we'll just go in 80. So if whatever condition, so if x is anything with 0, then x equals 1, else x equals 0. So in any case, the number of characters that I am sucking up, Because if you go your condition will be anywhere from 4 to could be 3, because it could be x equals 0. Anywhere from 3 to 7, and then each of these things is likely going to be longer than 3. So the overhead of an if-then-else is is quite a tax. You have the 1, 2, 3, 4, 5, 6, 7, 8, 9. So you have 10, which means not even counting. So if all the other ones are on an average, it's 5 characters for the condition and the then and the else. It is so that's 25. So if that were the case, then 25 characters you have at most 9 and some change if then else statements. So what do we do is we have we have how BASIC overloads the equal operator and making for truth. So if x is random 3, y equals I'm going to go x equals 2, not x equals 20. So y equals x equals 2, which doesn't do an assignment. We should actually probably print it. Print y, run. Minus 1, 0, minus 1, minus 1. So what does it do? It checks to see if x equals 2, and if x is equal to 2, it then makes y minus 1. What possible use is that, you may ask? Here's I think, going to be my first real practical example here. So 10 CLS. X equals, it's going to be 16, y equals 8. So 20, we're going to poke 10 to 4 plus x plus y times 32. 30 I string equals inkey string, and for 999 we're going to go to 999 because we need to edit to 30 at the end. If I string equals that, then 30. List looks right. Oh, syntax error 20. Nope. X. Okay. So, got a little dot right there, and what I'd like to do is I'd like to move them, and that's exactly what I'm going to do. So 40. There are some characters where I can go if I $ equals character 94, then y equals y minus 1, else if I $ equal character 10, then y equals y plus 1, else if I $ equal character 8, then x equals x minus 1, nope, yep, 1, else if I equal character 9, then y, x equals x plus 1. Cool, run. So now, and still knows works, and 30, if I and then, of course, 50, go to, I need, after that, so 35, poke, 1024 plus x plus y times 32, poke 32 there, And then we'll call 9999, go to 20, list. We're going to renumber it. So now everything's got 10s. So now run. Oh, I didn't want 32, I guess. That's alright. It's the idea here. Yay! So move the guy. Of course, I have no boundary checks. If I decide to go off the screen, it's just going to write something weird into memory, and who knows what would happen. But, so, I won't. So, looking at line 50, we can, gotta move quickly here. So, well, we'll remove 50. So, y equals, so if I $ equals CHR94, then I want to subtract 1 equals y plus I $ equals CHR94. And then if it's 10, I want to add 1. So minus I $ equals CHR $10. And x equals x plus I $ equals CHR $8 minus I $ equals CHR 9. Got the right number of parentheses? I think I do. So then I can get rid of 50. And that's already, if it works, whoop, TM. Oh, okay. Of course. Okay, so I got so much better. Got my logic down to there. Now, really, I can make that even shorter because I have all those CHR $, and that's if we actually just take the ASCII value, we then also get rid of the $, so we get rid of all the CHRs, all the parentheses around it. If I just took the ASCII value of I $ and tucked it into I. And so I can make that even shorter. And so that's the kind of thing that when you're working in a 10-liner, these are the tricks that you have to pull out, and I plan on pulling all of them out because, again, 10 print going down to 10. Yeah, that's right. See you next time.